And welcome back. All right, so here we go. Last section of 3.2, and here's some good news. You'll like this. Last day with limits. Okay, so you guys should be excited about that. All right, but one thing we're going to talk about today is that we've always seen the limit or the definition of a slope at a point, the derivative at a point, in one way, and you might have thought that was the only way that it can be seen, and that's not true. Here's the case. It's called the symmetric difference method for finding a derivative, and it's given by this big giant mess that's all right here. So how can I find this out? So provide the okay, so I need to find this out, and you use the symmetric difference method so to find the slope at any point for that function. Before I do that, I want to analyze what this junk is. Okay, so to me it looks like a difference quotient again, all right, but using different points. So let's take a look. All right, so if I have my graph here, and here's my graph, and there's my graph, all right, and I was looking at this point right here as my A. Okay. We'll take a look at what it's doing. F of A plus H. Well, we're used to seeing that, so here we are. F of A plus H. So here I'll make that be A plus H. Okay, there's that. But look what it has also, A minus H. So remember that distance was H. So A minus H, well, that's right here. Okay, that's A minus H. Notice that distance is also H. And look what they do. What they do is they say if I take the slope, there's my secant slope right there. That's what I'm using as a secant slope. And if I make h go to closer and closer to 0, closer and closer to 0, it's going to squeeze in on the derivative or the tangent slope at that point. Okay. Hopefully that drawing makes a little bit of sense of what's happening. So now we're going to actually do the problem. Okay. So on this first one here we go. So I'm just going to start plugging in since we already know what all this should mean. So it's a limit as x goes to 0, not x, h goes to 0. And f of a plus h, so it's going to be 2 over a plus h minus 2 over a minus h all over a plus h minus a minus h. That's all great. All right, so then what I'm going to see here is I want to go ahead and got a complex fraction, so I want to get a common denominator from the top here. So here we go, a plus h times a plus h. Okay, this one's going to be a minus h over a minus h. Going kind of quickly here, this is then turned into the limit as h goes to 0 of 2a minus 2h minus quantity. See if I can squeeze this in here. We've got 2a plus 2h all over, well, a plus h times a minus h, well, that's just a squared minus h squared all over. Now I got to do some analysis, and this is going to be a minus a, well, that's just going to go away, and h minus the negative h, well, that's just 2h. Well, wait a minute, what do you mean 2h? 2h, that's, oh, here, this here is 2h, because you had an h on this side and h on this side, so my difference in my x's is 2h. Alright, well, I'm going to go ahead and simplify the top now. When I do that, that becomes the limit as h approaches 0 of, well, 2a minus 2a goes away. Negative 2h minus 2h is a negative 4h all over a squared minus h squared times 1 over 2h. And again, I'm going to go ahead and simplify. And I'm going to say that this goes 2. It becomes negative 2. And I get an answer that's, I got limit as h goes to 0, negative 2 over a squared minus h squared, which is just equal to, as h goes to 0, negative 2 over a squared. And you ask yourself, what does that all equal? Well, that's all equal to f prime at any point A. That's my slope at any point A. Ta-da! We're done. So why did I show this to you? All right, I showed this to you for a couple of reasons. Okay, one, to show you a different way. Okay, two, this is how the calculator calculates the slope. And I want you to know the limitations of this, because the limitations of your calculator, it's just a machine. You need to be smarter than it sometimes, okay? So where it's going to have problems, where your calculator has problems, all right, is here, all right? And why does it have a problem here with these specific ones? Because remember my drawing? If I want to find the slope here, now you and I both know the slope here at 0, okay, does not exist, because the slope from the left and the slope from the right do not match up. But your calculator, it's just going off of a formula. And so here, I'm over here at 0 plus h, and here I am at 0 minus h, and what I get when I go up and up, what's my slope of that secant line? Y'all better be saying 0. So how does this play out on your calculator? So let me show you how this works on your calculator. All right, so here we're going to go to your calculator. We're going to go ahead and go here, and I'm going to clear this out. And so what we're going to do is we're going to go to math, and then the number 8. If you can't hear me, I'm going to show you. I'm going to scroll all the way down to the number 8. Okay, there I am, n-deriv. That means the number derivative. In your book, it'll say n-dir. Okay, n-dir is the same as n-deriv. That means find the numerical derivative using your calculator. Okay, so if you see n-dir in your book, think calculator. So I go ahead and press enter, n-dir, and I press enter. And it's got a whole bunch of stuff for me to fill out. Oh my goodness. So then we have to go back to the beginning of 3.1 where we talked about, well, what is this d dx, okay? d dx, that's what's supposed to be there. Take the derivative with respect to x. So it's got to be x. Well, what's my function? That's what we're going to put here as our function. And we're going to go ahead and say that this is going to be math, because it's the absolute value is what I'm going to put in, number, absolute value, x. And this last one is saying, well, I have the derivative, I have my function is, you know, absolute value of x. This last part is where do you want me to evaluate the derivative? Well, you want it to be evaluated at x equals 0. And enter. And it says it has a derivative, and that derivative is 0. And like I said, we both know that's not true. So at this point, you need to be better than your calculator. Okay, that's why it's important and imperative that you guys know what your functions look like. Okay, that's why you need to know your parent functions. All right, good deal. Next. So I come over to here. That's why I showed you that. So now how can I use my calculator to help me out by writing the equation for a tangent line for g of x when x is equal to 2.3? So this one I'm going to handle a little bit differently. Okay, so when I'm going to train you is that when you have the calculator and you see a function in a question and it's in the calculator part of your test, automatically take that function and put it into y equals. So I'm going to go over here, I'm going to put that function into y equals. And that's going to be the x cubed, okay, minus 1 over x. X, there we go. And I go ahead and I hit my graph of this, not graph of this, I'm going to go quit. Okay. And so what do I want? I want to find first, right? Because it's asking for an equation. So what do I need? I need a slope and a point. So I put that in there, and then I got to realize, okay, what do I need? I need a slope. I need a point. They give me a part of the point. That's 2.3. They don't give me the slope, but that's what I need to find. So my slope, let's find slope. So I want to find the numerical derivative. Again, that's math 8. You can just press the number 8. And then you're going to take the derivative with respect to x. Now my function. Now here's the really cool part, is that I put the function into y1. So guess what I can do? I can press the button down here, vars, go over to y vars, and I want the functions. That's number 1. I want y1. I press enter. So I'm going to take the derivative of y1. Now where do I want it? I want it at 2.3. 2.3. And I hit graph. Bink. Not graph. I want to hit enter. and it gives me 16.0590369. So where do you stop? In calculus, you stop with 3 digits. So I'm going to put 16.059. Okay, 16.059. And it can be truncated, or it can, which means I just cut off after 3, or I can round, your choice. So now I want to go ahead and I want to find out f of 2.3. So I need to find out g of 2.3, right? So I can find out the second part of my point. Well, again, your calculator comes in handy. So what I can do is I go back again to vars, yvars, press enter. I'm going to go to y1. And what do I want? I want y1 evaluated at, so I put the little parenthesis, at 2.3. I hit enter. And there it is, 11.7322173. Again, 11.7322. So I write that down, 11.7322. 2. All right, then I use this to make my equation. So that would be y minus y1, 11.732, is equal to my slope, 16.059 times times x minus 2.3. And there you go. There's your equation. It may look ugly, but that's all we had to do. And look how remarkably easy that is. All right. Now you're all killing me right now, right? You're sticking knives in me, right? Because I made you do all that limit stuff, and now your calculator can do it for you. So I keep going. One more slide here. So this one says, now I can not only use my calculator to find the derivative at a point, but I can now use it to graph a derivative. Okay, I want to do x squared. Okay, so let's go ahead and put that into my calculator real fast. So I go to calculator, I'm going to go up here to y equals. I'm going to change this to clear. I'm going to say x squared. X, oops, not squared. Yeah, clear. I do x squared. Let's see here, delete. There we go. Enter. All right. Now, how do I graph the derivative? So that's my graphing of a point. So how can I graph the derivative? The graph of the derivative, well, guess what? Math 8. Again, Math 8. Okay, I want to take the derivative with respect to x. Okay, what function do I want to take the derivative of? Okay, well, I want to go ahead and take the derivative of y equals x squared. Okay, well, y1. So again, vars, yvars, enter, y1. Okay, and I want to take it, well, now this is the part. I don't want to just take it at one x point. I want to take it at every single x, right? Because I want to graph this. So watch this. You can just hit x equals x. And that won't be able to do it at every single point. And now when I hit graph, this is where it's cool. Here comes x squared. Boom. And then here comes really slow x. There's the derivative. Huh. That looks like a line. I wonder if that's a pattern. We'll find out more. But there you are. Okay. This right here. There's f of x. And one that was really slow to do because your calculator is crunching lots of numbers was, you know, y prime. Okay, the derivative. So that being said, hope you're equally amazed. Now, if you want to, I'm going to let you do this one back on your own. Remember, that's 1 over x. If you want to try it, take a look at it, see what it does. It's kind of cool, too. All right. Otherwise, here you go. This is your homework. If you have any questions, remember to write them down and put them in there so I can look at it. All right. Talk to you guys later.